Good day everyone. Already you have learned 4 properties. Today you are going to learn the 5th property and sums based on that. Integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. In this there is one condition. This c which we have introduced in the RHS, for that it is a less than c less than b, that c should lie between a and b. That is very important. It is very easy to identify where this property is to be used. We will use it when you have a modulus function as an integrand and greatest integer function as an integrand. Okay. So we can easily identify that we have to use this property once you get that type of sums. Now, modulus functions is the most common thing. Before going into the sums, let me explain certain facts about a modulus function. In the lower classes, you know, modulus means it is absolute value. That is, whether you have a plus or minus within the modulus, you will take it as a plus, isn't it? That is, modulus plus 2 is 2. Modulus minus 2 is also 2, like that. But now let us learn something more about modulus functions. Okay? Now, you consider a modulus function mod x minus 1. Now actually, it is positive, that's right. But you know, let us analyze. If the x is greater than or equal to 1, definitely that x minus 1 is going to be positive, right? If the x is lesser than 1, then inside you will get a negative value. So we will introduce another negation so that the value will be positive. Okay? So now actually we have to write like mod x minus 1 is equal to x minus 1. That is the same positive quantity when the x is greater than or equal to 1, and it will be equal to minus of x minus 1 when x is lesser than 1. This is the interpretation of a modulus function. How do you get this one? Equate what is within the modulus to 0. When x minus 1 is equal to 0, x is equal to 1. When the x is greater than or equal to that value, the inside, that value we take as it is because that will be positive. But when x is lesser than 1, you will get inside a negative value. To get a positive, we introduce another negation, so that will be minus of x minus 1. Let me give you one more example. You consider mod x plus 4, okay? Equate what is within the modulus to 0. What do you get for x? X is equal to minus 4. So now you can write this is equal to x plus 4 when x is greater than or equal to minus 4, right? This mod function will be equal to minus of x plus 4 when x is lesser than minus 4. Is this clear? Because this is the concept we are going to use for sums in which we will be using this property. This is mostly used for modulus functions. Are you clear about the basics? Okay. First sum. Integral minus 3 to 3 mod x plus 2 dx. Now, this is that integral a to b f of x dx. The f of x is a modulus function. So, you definitely know you have to make use of this formula. So, I have to find the c. Then only I can write like this, right? Now, this is my a and this is my b. That is, the lower limit is a minus 3 and the upper limit is b, which is 3. Now, to find that c, you equate what is there in the modulus to 0. So, you get x is equal to minus 2. That is your c. Okay? So, now I can write this is equal to integral. Okay? A to c. A is minus 3. This is minus 2. f of x dx, I will come to this later, plus integral minus 2 to b is 3 f of x dx. The f of x is going to differ for both these. Now I will come to that. Now you just draw a number line. Write your a here, which is minus 3, your b is plus 3, and you have got a minus 2. This is a, this is c, this is b. The c lies between a and b, right? Now I told you, for a modulus there are two interpretations, that is mod x plus 2 will be equal to x plus 2 when x is greater than or equal to minus 2. It will be equal to minus of x plus 2 when x is lesser than minus 2. Remember that. So now you have now two intervals, minus 3 to minus 2, minus 2 to 3. Okay, see the two integrals here. Now we have to find out where our modulus function is going to be positive and in which interval it is going to be negative. Now, if you consider this interval, this side, that is to the left of minus 2, will be all lesser than minus 2. To the right of minus 2, all values of x will be greater than minus 2, correct? So now, definitely, the modulus x plus 2, because it is lesser than minus 2, it will be minus in this and that will be plus here. Is it clear? So now I will write, it is integral minus 3 to minus 2. In that interval it is negative. So it is minus of x plus 2 dx. And for this one, where your x is greater than minus 2, it will be positive. So that will be x plus 2 dx. So this is the main thing you have to understand in this type of sums. Hope it is clear to you. So now it is simple. We have got two sums, right? Two integral sums. Rather, the f of x except for the sign it is same. So the integration part will be same. Only the limits vary and you have a negative sign here, right? Now, for the first integral, let me take a minus here. I can write that as x plus 2 the whole square by 2. I have already told you, for a linear algebraic function with an x term and a number term, you can do it in two ways. One is doing them separately, integrating separately. Other one, taking like this, okay? Then, within now the limit is minus 3 to minus 2. For the second, it will be x plus 2 the whole square by 2 again. Now it is minus 2 to 3, right? Now, let me take this 2 outside. So, I will be getting minus 1 by 2. The upper limit is minus 2. Now, you will know why I follow this particular method. Now, see, when I substitute minus 2, this will become 0. So, my upper limit vanishes. Coming to the lower limit, minus 3 plus 2, that will be minus 1. Minus 1 the whole square will be plus 1. So, I will be getting plus 1, but you will have a negation because upper limit minus lower limit. Is it clear? Coming to the second term, you take that 1 by 2 out here also. Now coming to the upper limit, 3 plus 2, 5. 5 squared will be 25. Then minus lower limit. Minus 2 plus 2, 0. So the lower limit vanishes. So see here, here the upper limit vanished, here the lower limit vanishes. So our calculations become simpler, right? So here you will be getting plus 1 by 2. Here you will be getting 25 by 2. So total 26 by 2, which gives you 13. Is this sum clear to you? The first thing you have to understand is how to find the C. Okay? For that, what do? You equate what is within the modulus to 0 and find the x value. Then you are getting now two intervals. See in which interval the modulus function is positive, in which interval that will become negative using the interpretation of modulus. Then you get at two sums, then do the integration and substitute the limits. Hope this sum is clear to you. We'll do one more sum now. Second sum. I is equal to integral 0 to 1 mod 5x minus 3 dx. I told you, wherever it is modulus function as the integrand, you are going to use this property. So first, there is no doubt about it, right? Now we know a, that is the lower limit, that is 0, the upper limit is 1. So now we have to find the c. How are we going to find? Equate what is within the modulus to 0. So you are having 5x minus 3 equated to 0. 5x is 3, so x is equal to 3 by 5, right? So that will be your c now. Now let us have a number line, okay? Write the a here, this is a, write the b here, and this is your c, which is 3 by 5. Okay? So now, using this property, we are going to write it as, okay? This is the integral a to b f of x dx. That I am going to write it as integral a to c, okay? F of x dx plus integral c to b f of x dx. Now, as we have done in the previous sum, let us see where it is positive, where it is negative. You know, mod x minus 5x minus 3 is equal to 5x minus 3 when x is greater than or equal to 3 by 5. And it will be minus of 5x minus 3 when x is lesser than 3 by 5. So this is lesser. Always the left, no, to the left of c will be lesser, to the right of c will be greater. So this will be minus and this will be plus. So now coming here I will write, this is integral 0 to 3 by 5. That is, it is the lesser one, so negative 1 minus 5x minus 3 dx, okay? Then plus integral 3 by 5 to 1. You will get the positive thing now, 5x minus 3 dx. Hope now you have understood how to find the c and how to find the positive, negative and write the two things, okay? Now it's just two sums. So now let us take the minus out here. So if I integrate, I will be getting 5x minus 3 the whole square by 2 into 5. What is this 5 part? That is the coefficient of x, okay? Then 0 to 3 by 5 plus for the next term, it is 5x minus 3 the whole square by 2 into 5 again. It is now 3 by 5 to 1. 3 by 5 to 1, okay? So now let us take this 10 outside, so it will get minus 1 by 10 here. When you substitute the upper limit, 5 into 3 by 5, the 5 will get cut, you will get 3. 3 minus 3 is 0. So here the upper limit vanishes, minus the lower limit. If you put 0 here, 5 into 0 is 0. 0 minus 3 is minus 3. Minus 3 the whole square will be 9. So you get a 9 here. Plus take again 1 by 10 out. If you put 1, 5 minus 3, 2, 2 squared is 4, right? Then if you substitute the lower limit, that will be 0. So in these cases, either the upper limit or the lower limit becomes 0. Okay, you have seen that in the previous sum also. So now what do you get here? This is 9 by 10 and that will be 4 by 10. So you get 13 by 10 and that is the answer for this sum. Is it clear? So the two sums we have taken one single linear modulus function and we found the c. Then we decided in which interval it is positive, the modulus function, in which interval it is negative. Then like two sums we integrated, we substituted the limits. Okay. Before going to the third sum, let me explain one small concept. Now you just consider integral 0 to 5 mod x minus 5 dx. Here, if you equate x minus 5 to 0, what is the value you are getting? X is equal to 5, right? That means actually in this number line, you will get 0 here, 5 here, and your C value coincides with one end value. That means you are actually having only one interval 0 to 5, because the C coincides with the B. It may coincide with B, it may coincide with A. Okay? So now we have only one interval. You know, here everything is lesser than 5 only. So you will get for this mod x minus 5 only minus of x minus 5. You won't get actually two parts. Here the positive thing does not arise because you don't have anything greater than 5, because everything is to the left of 5 only. You don't have that side. Like this, sums may come. You should know that. In that case, you will be getting only either minus or a plus like that. Okay? So, you should know that also. Now, let us come to the third sum. In the third sum, it is given integral minus 5 to 0 f of x dx, where f of x is equal to, it is now a combination of three modulus functions. You can have a plus sign or a minus sign in between, that doesn't matter. It doesn't contain only one simple linear modulus function. Now you have got mod x plus 2 plus mod x plus 5. That means I have to decide my f of x for each interval based on all the three modulus functions. I have to take into consideration all the three. Anyway, let me proceed slowly. Now, first, if you consider this mod x, you know the C value for this alone, x is equal to 0. That coincides here with this, right? If you consider the third one, x plus 5, mod x plus 5, x value will be minus 5. That coincides here with the lower limit. That means I am left with only this one, which will come in between. So this is happening in this sum. Not necessarily it will be like this. Okay? So for this particular sum, this and this, that x values coincide with the lower limit, upper limit. So now if mod x plus 2, that part is 0, I get x is equal to minus 2. That means here I have minus 5, here I have 0, here I have minus 2. So now, even though it consists of three modulus functions, I am now getting only two intervals, right? That is minus 5 to minus 2 and minus 2 to 0. Now, for each interval, I have to get what is my f of x considering all these things. You know clearly, mod x is equal to x when x is greater than 0. But you know there is nothing greater than 0. So that is not going to come. So definitely mod x will be equal to only what? Minus x. Coming to this will be equal to x plus 2 when x is greater than this. For this part, it will be negative. Okay? Coming to the third one, x plus 5 will be equal to x plus 5. That is mod x plus 5 will be equal to x plus 5 when x is greater than or equal to minus 5. That means everywhere. It will never be lesser because you don't have anything less than minus 5. Okay? So these things you should have in your mind. So now I will write f of x is equal to, okay? That is, since it is not just one modulus, I will write my f of x clearly. That is, for this interval I am going to write now. That means it is lesser than minus 2. So definitely lesser than 0 also. So here I will get a minus x. Okay? Here I will get a minus x plus 2. Okay? Here this is greater than minus 5. Here there is nothing less. So that will be positive for me. So if I remove the bracket, 1 minus x and 1 plus 6 will get cancelled. I will get minus x minus 2 plus 5. So that will be minus x plus 3. Okay. So in this particular interval, I am checking about each modulus, whether it will be plus or minus. Now, what is the interval I am considering? Minus 5 less than or equal to x lesser than minus 2. That is the interval I am now considering. Okay. Then, when I come to the next one, that is for this interval, when I come to that, that will be greater than minus 2. Okay. That means it will be greater than minus 5. So, these two will be positive. But this will be negative. So, you can write here minus x. Then you will get plus x plus 2. Then plus x plus 5. So, 1 minus x, 1 plus x will go. You will be getting x plus 7. That is when minus 2 less than or equal to x lesser than 0. Do you follow this, how to find the f of x? For each interval, you have to consider each modulus, whether it is positive or negative. Actually, you can think, why not we do it as 3 sums? We can do each one splitting into intervals. You can do, but that is definitely lengthy. And you will have sometimes 6 integrals up to that. Because for each one you may get 2, so you may get 6. So if you find the f of x, it will be definitely either 2 or 3 alone. So that will be easy. Hope you understood how to write the f of x. So now I will write the given I, that is minus 5 to 0. Okay. F of x, I will write that dx is equal to. Now straight away I will come to minus 5 to minus 2. In that I have already found it. So minus x plus 3 dx. Then plus minus 2 to 0. I have got now x plus 7 dx. Okay. So now it is just 2 sums. Here if you want, it is better you can take one minus out, because the x will be positive, so that you may not forget to put 1 by minus 1. So here I will take a minus out. So it will be x minus 3. So I get x minus 3 the whole square by 2. For this one I will get x plus 7 the whole square by 2. This will be minus 2 to 0, and this will be minus 5 to minus 2. Okay. So now for the first one, I will write minus 1 by 2 out. Now the upper limit is minus 2. So minus 2 minus 3 will be minus 5. Minus 5 the whole square will be 25. Then minus. The lower limit is minus 5. Minus 5 minus 3 is minus 8. Minus 8 square will be 64. Then take 1 by 2 out. Now it is 0. So 7 square. So you will get 49 minus. Here it is minus 2. So you will get 5. 5 square. That will be 25. Okay. So now you are getting here it is 25 minus 64. So that will be 39. Minus into minus will become plus. So 39 by 2. Here it is 49 minus 25. That will be 24 by 2. So you will be getting now 63 by 2, and that is your answer. So this is another type where your f of x consists of 2 or 3 modulus functions with a plus sign or a minus sign in between. Is this sum clear to you? Now see the fourth sum. I is equal to integral 0 to 2 modulus x squared plus 2x minus 3 dx. What difference you see in this sum? Here you have a quadratic which can be factorized within the mod. In the previous sum you had just a plus minus linear functions. Now you are having a quadratic, that means it is a product of 2 linear functions. Okay, so that will be the next model. So here you can factorize it and you can write it as mod. What will you get now? You will get x plus 3 into x minus 1 dx. If you factorize this quadratic, you are getting two linear functions. Okay. So now here again, your a is 0, right? A is 0, your b is 2. Now let us see. If you equate x plus 3 to 0, you are getting x is equal to minus 3. But that doesn't come in the interval a to b. Because it is lesser than a, we have to omit that value because that interval will not come. If you come to that other one, if x minus 1 is equal to 0 gives you x is equal to 1. So now your c is 1. So you get one value. So don't expect all times it will be like that. It all depends on the sum and on the limits only. So here I get again only two intervals. But here for each interval I have to check what happens to the product. In the previous sum we saw what happens when we add everything. Here we have to see what happens to the product. Okay. So now the first interval is going to be 0 to 1. Okay. If you consider 0 to 1, that means it is to the left of 1. So it will be all lesser than 1. If it is lesser than 1, okay, then that x minus 1 part, that will have a negation, correct? But when you consider the other one, x plus 3, here you know mod x plus 3 will be x plus 3 when x is greater than or equal to minus 3. I think it is better I write it because you may get confused otherwise. Mod x plus 3 will be equal to x plus 3 when x is greater than or equal to minus 3. It is minus of x plus 3 when x is lesser than minus 3, right? But this is not going to come for us because we don't have this. Then as far as that mod x minus 1 is considered, that is x minus 1 when x is greater than or equal to 1. That is minus of x minus 1 when x is lesser than 1. You know this is lesser and that is greater. That means you know, now if you consider this interval, this is positive and this is negative. So what will be the product? Plus into minus. So this will give you the total on the whole negation. So this quadratic, that will have a negation there. When you come to this interval 1 to 2, this is going to be positive and that is also positive. So plus into plus, so you are going to get a plus here. Okay. So now I can write this as, I will write it as first 0 to 1. You know it is negative, that is the total quadratic, a product of this. I can give you a negative sign here, dx. Then coming to the next interval, 1 to 2, that will be positive. So x squared plus 2x minus 3 dx. Okay. So the last sum, the method was a bit different. Now because it is a product, it is different. Okay. So now, take the minus out. If you integrate, you will get x cubed by 3 plus 2 into x squared by 2 minus 3x within 0 to 1. Coming to this one, you will get again x cubed by 3 plus 2 into x squared by 2 minus 3x within 1 to 2. Right? So now minus is out. The first one, it is 1 by 3. X cube, that is 1, 1 minus 0 is 1. So straight away I am writing 1 by 3 because it is easy calculation. Here this and this will go. X squared is 1 squared. Then minus 0. So you will get there only 1. Here it is minus 3 into 1. Then other one is 0. So you are going to get. Okay. Now coming to this one. Now I will write here it is 1 by 3 into 8 minus 1. 2 cube minus 1 cube. So 7. Okay. This and this will go. So the second part will be 2 squared is 4 minus 1 squared is 1. Minus 3 into 2 minus 1. Okay. So now let us calculate. What do we get here? So here I get, yeah, minus is outside. Okay. So here you get minus 2. So that will become now 2 minus 1 by 3 here. And here I will get 7 by 3 then plus 3, then here it is minus 3. This and this will go. Now take 3 as the LCM. You will get 6 minus 1 plus 7 by 3, right? So you will get now 6 plus 7, that is 13. 13 minus 1, 12. 12 by 3, which is 4. So the third sum and fourth sum are a bit different. Hope you have understood that, right? So today you have learned the property integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. When do we use them? For modulus functions to start with. In the modulus functions, today we saw 4 example sums. The first 2 were simple one linear modulus function. The third one was a sum of 3 linear modulus functions. Then the fourth one, a product of 2 modulus functions. Everything we have considered only algebraic functions today. In the next video, let us see few more models where I will consider trigonometric functions. Okay, hope it is clear to you. This become clear first and then we will go on to the next video. Thanks for watching the video. Share it with your friends and classmates.